Okay, so we are going to determine if functions are even, odd, or neither, okay? I'm going to say something. No, I'm not going to say that. So what we're going to do is, got to get my brain together. It's talking about the function. So if you see right here in the first one, it says if f of negative x right here is equal to f of x. So what that means is if I take a negative x and put it in place of x, it's my function, and I simplify it out. If it equals the original function, if nothing changes, okay, all the signs are the same, everything's the same, then that is going to be an even function. Okay, so if you plug in a negative x and it works out to be exactly the same thing that you started with, it will be an even function. The next one says if we plug in negative x and everything has changed the signs, so it's going to be the opposite. So like if you have x plus 3 and you plug it in, I'm sorry, let's do x squared, x cubed minus 2x. Okay, if you plug in a negative, that's going to change the sign of everything. And so that means it's going to be an odd function, and it'll be easier to understand once we actually get to a couple of examples. And then if you plug in a negative x and it doesn't equal the original and all of the signs haven't changed, maybe one of them has, but not all of them, then it's going to be neither. Okay, that's what that last one says. And again, it's probably a little bit more difficult to understand explaining it like this until you see how it works in action, okay? So again, if you plug in negative x and you get exactly what you started with, it's even. If you plug in negative x and all of your signs have changed, it's odd. And if you plug in negative x and it's not the same or all the signs haven't changed, then it's neither.
So it's just like you plug in like negative x or you plug in.
Yeah, negative x is what we're plugging in every time. Everybody ready? Okay. All right, so we're going to start with number 1, and it's the directions just to determine whether the function is even, odd, or neither. So like number 1, it's f of x is equal to x squared minus 3. The only place we're plugging in a negative x is the right side of the equation. The f of x doesn't really matter. What matters is everything else, okay? So what I'm going to do here is I'm just going to leave the f of x, but I'm going to put a negative in there because that's what we're doing. And when I plug it in, anytime there's an exponent attached to that x, when you plug it in, you want to put the negative x in parentheses with the exponent on the outside. Okay, so everywhere there's an x, I'm plugging in a negative x. That second part of the equation doesn't have an x, so that doesn't change. So think about this. If I do negative x times negative x, that's negative x squared. What does that turn to be? X squared, right? It's positive, negative times negative. So it turns out that it is x squared minus 3, right? So what I want to compare is this piece to my original. If they are exactly the same, that means it is an even function. If all of the signs have changed, it's odd. And if it's not either one or the other, then it's neither. So what do you think about those two? Are they exactly the same? Yes. So this one would be what kind of function? Even. And that's all we write. That's our answer, is even. Does that make a little bit of sense? All right, so for number 2, we're going to do the same thing, except for this time we're plugging in negative x into this g function. Remember, the letters don't mean anything other than that's a different function, so we call it by a different name. So we're going to do this. We're going to take, we're going to plug in a negative x. Sorry, pen's not wanting to write. We don't really concern ourselves. Let's see, I'm putting F instead of G. Try that one more time. So I want to think about this. If I do a negative 5 times, a negative times a negative, that turns positive, right? Times a negative goes back negative. Times another negative goes back positive. Times another negative will make it negative. So negative x to the 5th is just going to be negative x to the 5th, okay, because it ends up being a negative. If you have a negative an even number of times, it turns positive. If you have a negative an odd number of times, it turns negative. What about if I do x to the 3rd? Is that one going to end up being even or, negative or positive? Negative, right? Which is essentially like this. If you add a negative, what's the better way to write that? Just minus. So we want to compare the original to the result. Is it exactly the same? No, so it's not an even function. Did the sign of everything change in that? Yes, I started out with a positive x to the 5th and a positive x to the 3rd. I now have a negative x to the 5th and a negative x to the 3rd. So since all of the signs have changed, what are we going to say about this one? It's odd, yeah. Does it make a little bit more sense now that you see it in action? And then we're going to do the same thing for h. So if you will, go ahead and set it up. Plug in your negative x. See what happens with the signs of each term. Again, if nothing changes, it's even. If they all change, it's odd. And if there's any other combination, if one changes and the other one doesn't, it's neither. Okay, if none of them change, well, it wouldn't be that because that would make it even. So I'm going to do a negative x squared minus a negative x. If I square a negative, what does it turn? Positive. And then if I subtract a negative, it also turns positive. So I want you to compare the original to the new one. Is it exactly the same? No. Did all of my signs change? No. One of them did, but that doesn't help me to determine even or odd. It tells me that it is neither. Okay, so that's how we do these things. Plug in your negative x, work it out. Is the sign going to change? Is it not? If it's exactly the same, it's even. If every sign has changed, it's odd. And if only one of them has changed, it is neither. Anybody have any questions? Why does it matter whether it's even or odd? We'll get to a point where we can look at a graph and we'll determine, or not a graph, we'll look at a function, determine whether it's even or odd, and that can help us graph because even ones have a different end behavior than odd ones do. Okay. Try those two. Again, remember, plug in negative x, simplify it out with exponents or whatever. In this case, it's an absolute value as well. If your function is exactly the same, it's even. If all of your signs have changed, it's odd. And if it doesn't fit one of those two categories, it's going to be neither. With the absolute value, what's the absolute value of a negative? A positive, right? So with this one, it's going to seem a bit different. So if I do the absolute value of negative x, that's really just x, right? The only difference here is because it's an absolute value, we want to keep that just so that you can tell whether the equation is even or odd. We just know that it's no longer going to be negative once you take the absolute value. So what would that be? It would be even, right? Because it technically didn't change. What about that last one? Plug it in, work it out again. If they all changed, it's even. I'm sorry, if they're the same, it's even. If they all changed, it's odd, and if it's any other combination, it's going to be neither. If I cube a negative, what is the result? Positive or negative? Negative. So we're comparing the original to the new. What do we think? Even, odd, or neither? I got two answers, odd and neither. If every sign changes. If it's only one of them changes, then it's neither. Even is nothing changes. When the whole thing changes. So like all terms would have to change. So like, yeah, so like look at number 2 up here. The original one was the x plus 5 or x to the 5th plus x to the 3rd. My new one is a negative x to the 5th and negative x. Do you see how both signs changed? That makes it odd. Does that make sense? So what is number 5? Neither, yeah. Everybody kind of okay? If you'll write down both of these, we'll different than what we've done before. I want to talk to you about the function before we start plugging things in. We haven't dealt with negative exponents in a while. What does the negative exponent tell me to do? Move it to the bottom. So what I would like to do first, so that that negative exponent doesn't confuse us, is I would like to rewrite this function. If I have x to the negative 1, what does that become? 1 over x. Okay, so rewrite it like that. If you start with negative exponents, that way when you start to plug things in, that negative exponent doesn't confuse you a little bit more. Excuse me. Now we want to plug our negative x in. Everywhere there's an x, I'm going to put a negative x. That just gives me a negative 1 over x. If I add a negative again, what's the better way to write that as? Minus x. Exactly the same. Everything changed or only one changed? Everything changed, right? Let's not compare the first one. Let's compare the second. I'm going to re-highlight, sorry. Yeah, if that second term doesn't have an x in it, there's no way it's going to change, yeah. So what do we say? I'm sorry. Odd, okay, because everything changed. You could probably figure out 7. That was not too terribly difficult. It's not an absolute value. We're just plugging in a negative. We want to look to see if everything changes. I'm going to take that original function. Everywhere there's an x, I'm plugging in a negative x. Is there really anything I can do to simplify that any further? There's no absolute value, no nothing like that, no exponents. So looking at the original and the new one, what would we think? Neither. Just a little hint. Anytime you have a square root, it's always neither. Okay, that's one function that can't be even or odd because it only goes in one direction. The only functions that can be even or odd would be functions that have two sides to the graph. So just a little note, even functions would look something like a parabola, okay? Where both of your sides go in the same direction. They either both go up or they both go down. That's technically what the graph of an even function would look like. Now, there might be some stuff in between. Okay, it could be some weird funky graph that we would do like this. But do you see how either ends still both go up? They can either both go up or both go down. That would make it an even function. An odd function is more like a line where one of them goes up and one of them goes down. Or our cube function that we did, except for that's backwards, but you get the idea. Okay, so talking about the graphs yesterday and looking at the functions, what does it matter about even and odd? It matters about their end behavior. What does the end of the graph do? So that's why we need to know whether functions are even and odd so that we can decide what the ends of the graph do, which we'll pull all that together later. Anybody have any questions? We get the idea? Okay.